Hello and welcome. Today we're diving into a concept that's set to revolutionize space exploration, In-Situ Resource Utilization, or ISRU. Imagine setting up camp on the Moon or Mars, not with everything packed from home, but by living off the land. That's the core idea of ISRU, using resources found right there, on other celestial bodies. Why is this such a game changer? Currently, every single drop of water, breath of air, or gram of fuel needed for a mission has to be launched from Earth. That's incredibly expensive and complex. ISRU offers a path to generating essentials like water, oxygen, rocket fuel, and even building materials directly on site using local materials like water ice trapped in lunar soil, minerals in Martian regolith, or atmospheric gases. This drastically cuts down mission costs and makes long-term stays in space far more feasible. But how do we actually do this? The answer lies heavily in robotics, specifically autonomous systems powered by artificial intelligence. Think about it. Controlling a robot on Mars in real time is impossible due to the communication lag. Commands can take many minutes to travel each way. Therefore, robots need to think for themselves. AI and machine learning allow these machines to navigate tricky landscapes, identify resources or hazards, make decisions, and perform complex tasks without constant human hand-holding. We've already seen glimpses of this with NASA's Mars rovers, like Curiosity and Perseverance, using AI for driving. Future robots will be even smarter, adapting their strategies based on what they encounter. So, what jobs will these space robots have in an ISRU scenario? Pretty much everything. First, prospecting and exploration. Teams of robots will scout for resources, map deposits of water ice, and analyze the terrain. NASA's upcoming Cadre mission will test cooperative exploration with multiple lunar rovers. Next comes excavation and collection. Specialized robot excavators and drills will dig up regolith or ice, operating in harsh environments with abrasive dust and extreme temperatures. NASA is actively testing ways to dig into the Moon's surface to get at that valuable water ice. Then, processing and manufacturing. Collected materials go to robotic processing plants. Here, water can be baked out of regolith, or oxygen can be extracted from Mars' carbon dioxide atmosphere, something the MOXIE instrument on Perseverance has already successfully demonstrated. Imagine robots 3D printing habitats, landing pads, or tools using processed local soil. After processing, we need transportation and logistics. Fleets of robotic haulers could move raw materials and finished products, like fuel or water, around the base. Efficient coordination between these robots will be key. Finally, construction. AI-powered robots could build large structures like habitats and launch pads using those locally manufactured materials, saving the immense cost of hauling prefab structures from Earth. Development in ISRU robotics is moving fast. We're seeing advancements in multi-robot coordination software, tested in challenges like the NASA Space Robotics Challenge. Innovative concepts are emerging, like the WINE spacecraft designed to mine water and use it as steam propellant to hop around celestial bodies. Companies are building critical hardware like drills and robotic arms. And crucial field testing happens in Earth-based analog environments, like volcanic sites, to simulate lunar or Martian conditions. Looking ahead, expect even more sophisticated autonomy, perhaps even swarms of simpler robots working together. Of course, it's not all smooth sailing. Huge challenges remain. Designing robots that can survive extreme temperatures, vacuum, and abrasive dust is tough. Powering these machines, especially during long lunar nights, is a major hurdle. Ensuring reliable long-term autonomy and coordination is a complex software challenge. And the upfront cost of developing and deploying these advanced systems is significant. Despite these challenges, the path forward is clear. Robotics and AI are the indispensable tools that will unlock the potential of in-situ resource utilization. By enabling us to find, process, and use resources already in space, they are paving the way for a sustainable human presence beyond Earth, fundamentally changing how we explore and perhaps one day inhabit other worlds. Thanks for tuning in.